Hi guys, this is number 32. This is number 32. Okay, let's just read the question so we know what it's about. A river flows with a uniform velocity v. A person in a motorboat travels 1.32 kilometers upstream, at which time a log is seen floating by. So, let's say this is the river, and then we have our boat right here. So it travels upstream and for 1.32 kilometers. And then it sees a log. Whoops, wrong color. Where's the brown pen? It sees a log, and then it travels, the person continues to travel upstream for 36.9 minutes. So it continues traveling upstream for 36.9 minutes. And then it returns downstream to the starting point, so down to here, at which point it sees the log again. So it comes all the way back down, and then at that point, the log has also come back down, and they're now at the same point. So we have a couple of different variables right now. So let's define each of the variables we have. So let's call this distance that the boat first travels, let's label it as d. So d equals 1.32 kilometers. And then this part where it travels up here, let's label that as time 1. So that's where it goes from this log all the way upstream for 36.9 minutes. And then when it comes all the way back down, let's label this as time. This is time 2, which is unknown. And then at that time, and then we know that the time that it takes to travel from here upstream and then all the way back downstream, so T1 plus T2 equals this time, and let's label this as T3. So those are our 3 time variables. And then now we have to label our different velocities, because our boat is traveling one velocity. As it's going upstream, it's traveling against the current, and then when it's going downstream, it's traveling with the current. So when it's traveling upstream, let's call the velocity of this boat VB. And then let's call the velocity of the river, the rate of the current, VR. Okay, so now let's set up our equations. So we know that d equals, let's write down our unknowns. So d equals 1.32 kilometers, which also equals 1,320 meters. And it asks for meters per second of the current. So we're looking for VR, and it's asking for VR in terms of meters per second. So that's why I'm converting this to meters, and later on we have to convert minutes to seconds. So d equals that, and then we know that T1 plus T2 equals T3. So again, this is the time that the boat travels upstream and then all the way downstream, equals the same time that the log takes to get from the point where they first see each other to the point where they end, and then see each other once again. So that's our time. And then we know that, so since we don't know how far the boat has traveled from here upstream for 36.9 minutes, let's label this distance as x. So we can create another equation where x equals the velocity of the boat, and then since it's going against the current, you have to minus the velocity of the river. And then, so that So the velocity is times time. So position is velocity times time. And then since there's no acceleration, we don't have to worry about that. So the time would be t1. And then when it comes back down, that entire distance is x plus 1,320 meters. So it's this portion, which is x, and then this portion from here to here is 1,320, which, to simplify things, let's just call it d for now. That's bad. X plus d. So this distance from here to here, and then plus this distance from here back down. So it's that distance that the boat is going downstream. And then that equals VB plus VR, since it's going with the current, and then that's times T2. Right, and then, so those are the equations we can set up for the boat. And then now for the log, we can set up the equation, again, where its position equals a certain time times velocity. So the distance, again, is the same as d. So if you see this distance, it's still the same as this initial d. So for the log, let's color code these so it's all the same. So that distance, again, is equal to time 3. And then the velocity of the log, since the log itself has no velocity, it's just going with the velocity of the river. So the velocity that the log is traveling at is just VR. So now we have all our equations set up. So now we can start to make the systems of equation and start canceling out variables. So let's start with what are the relationships that we do know. So we know that let's take this equation and apply these three to that. So if we simplify this, and if we take this equation and write it in terms of T1, so we get T1, which is just x over this velocity, x over, too many markers. Okay, so v, the velocity of the boat, minus the velocity of the river. Okay, so if you see, this is just T1, so we got this from this equation right here. Okay, so that's T1, and then we add T2, which we get by doing the same thing. So that would be x plus d divided by, can you see the board, Kevin?
Yep.
Okay. VR plus VR, V of the boat plus VR. So you take this and you divide each side with the velocity. And so we have T1 plus T2, and now we have to equal it to T3, which we know is just distance, the d, over the velocity of the current. The same d over the velocity of the river. So that's our relationship right here. So now we see that we don't know x, so that's one unknown variable. We don't know the velocity of the boat, and we don't know the velocity of the river. So we have three unknowns in this equation. So one way we can simplify this so that we can take out some of those unknowns is we do know what T1 is. So if we know what T1 is, we can maybe use this equation right here to help cancel out the x, this x unknown in this first relationship. So if we plug in this part, v of the velocity minus the velocity of the current times T1, and we substitute that in for x, then we have only two unknown variables. So what that would look like, so the velocity of the boat minus the velocity of the river times t1, and then we divide that by the velocity of the boat minus the velocity of the river. And then we do the same thing for this equation right here. So we get the velocity of the boat minus the velocity of the river times time, t1, plus distance over the velocity of the boat plus vr. Okay. So this is just the x value that we substituted in. So you can see that from this equation, this second equation that we wrote. So this would all equal d over vr.
Okay, next we can cancel out the VB minus VR, and that leaves us with only T1. Next we can multiply the top and bottom of T1 by VB plus VR to get common denominators. Next we can add them together. Next we can distribute the equation. Now we can see that the VRs can cancel out. Next we can add the VBT1s together to get 2 VBT1. Next we cross multiply the equation. Next we distribute both sides of the equation. Next we can cancel out dVR. Next we can divide both sides by VB. And lastly we can set the equation equal to VR. And our final answer is d over 2t1.